All right. So I want to talk about exponential functions, and there's a reason I tried to spell functions with a K. Functions. So the reason I tried to spell exponential functions with a K is that K's are important in exponential functions. So I want to give you guys a definition, and this is a little tricky, so I need everyone's brain on. Levi, I need your brain on. Okay. The tricky part of exponential functions is that an exponential function has a very special form. So a function is called exponential if f of x is a e to the kx.
Alright, that looks familiar.
Okay. Other things that look similar are not exponential. Okay, are you guys ready for trick question time?
Yes.
Okay.
Is e to the x exponential? Yes, it is.
Yes, good. Maybe let's just make a
Thanks, Lee.
let me make a list. Examples over here, not examples over here.
Exemplary examples and exemplary for.
Okay. E to the x falls under the
Exponential. Not
the example.
Yeah, because an example is e to the x.
So my question to you is, what's a and what's k?
They're numbers. They're coefficients.
Isn't A 1?
In this case specifically,
Oh,
a is
one.
1 and k is
Right.
also 1.
Okay.
You guys with that?
With it.
Yeah.
Okay. How about, I'm writing this over here. I'm not committed to that. H of x is e to the minus x.
Stay committed to it. It's exponential.
Is that exponential? Is that
Yeah. Is this exponential or not?
Yeah.
Yeah?
Yeah.
Okay. So let's try a couple and see if we can decide.
Alright.
How about w of x is 2 to the x?
Man, that's not e. There's no e there.
It's not e, there's no e there, right? Okay.
No, there is. No, there is.
There's just e to the 0 power.
So close. The x needs to be in the power of the e, right? So it seems like I'm doing something crazy here, yeah? This is an example because you can write this as e to the natural log of 2 to the x, and then you can take the x down using the log rule. So this is e to the natural log of 2, which is a number, times x. Right, so this is exponential with a is 1 and k is the natural log of 2.
The natural log.
Yeah,
natural
e to
log
the
of
natural
2
log of 2.
Wait, natural log of 2 to the x is equal to the natural log of 2 times x. Okay.
So what I did, right, is I applied e and log to this thing,
Yeah.
right?
Yeah, you did.
So
Just one. They're like inverses of each
they're inverses of one another, and they're actual inverse functions, right?
Yes.
Those are full inverses,
Straight
like
up
good ones.
inverses.
So I got 2 to the x up here, and then I used a log rule. You guys remember the log rule I'm using?
I don't know what it's called.
So the log rule that I'm using is this one. Log of stuff to a power. Oops. Log of all of stuff to a power is a power times log of the stuff. Okay?
Yeah.
All right. Let's try another one.
Whoa.
Whoa.
No, yeah. No, yeah. That is.
Was that a yeah no or a no yeah?
No, yeah.
I'm still new to Northern California, so I'm still kind of learning this distinction.
No, yeah.
Are you going to make up a whole example?
I know yeah means that that's the right answer.
Yeah, that's, yeah.
So no yeah would be yes.
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 Yeah no.
You win. You win.
Yes, it's because you're not multiplying.
That's why I was like, no.
Right? If you were multiplying, you could maybe fiddle this around, right? But this is not a something to a power, maybe with a constant in the power and a constant out front. You guys see that? There's two terms here. This is a sum of exponential functions, but it is not itself an exponential function.
Okay.
In the same way that if you took two quadratics, well, you took two quadratics and added them together, right? Maybe the x squareds would cancel, and you'd get a line. So this is kind of one of those, right? Exponentials, when you add them together, aren't necessarily exponential anymore. They could be, but they're not necessarily. Can anybody give me an example where they are? Like where can you tell me something I could replace the 2 with here? Oh, if I had an e here, right?
It'd be 2x.
Then I'd get 2e to the x.
So not 2x to the e, yeah, you know what I mean.
Right?
Straight
You guys with that?
Yeah. With it.
Okay, so e to the x plus e to the x is an example over here. What else could I try?
Divide.
Oh, actually, let's try Levi's thing.
X to the e.
Is that exponential?
Alright, so if you put it as
Yeah.
e
Yeah.
to the...
So
no,
much
it's
confidence.
Not. It's not.
Yeah.
It's not an exponential
It is.
function. It's
No.
not.
It's.
Yeah, you wouldn't be able to bring that e down.
Yeah, you need to be able to like switch swatch the places, right? The variable needs to be in the exponent for it to be an exponential function.
Well, can't you?
This is what's called a power function. You guys know that distinction?
No.
Maybe not? So an exponential function, like the idea here, basically the thing you could remember is this is a number to a variable, right? And a power function is similar, but it's instead a variable to a number, like x squared or x cubed or x to the e or x to the square root of 2 or whatever. You guys cool with that?
Yeah.
X to the 1/2, for instance, is a power function. Right? So the square root is a power function, but it's not an exponential function. You guys good with that distinction? Okay, cool. Good job. Why? Why? Why would you do this?
What?
Why? Like, why am I introducing this? What do these get used for?
Population growth.
All right, you guys know that.
Banks. It's business.
Populations. Money.
Death of a star.
What's that?
Death of a star.
Yeah.
Radioactive decay.
Dynamics.
Yeah, actually, dynamics is a good. You guys know what dynamics is?
Change over time.
Yeah, dynamics is kind of the study of repeated iteration of a function. So this is like you keep doing something over and over and over again, like having a day. My dog does dynamics really well. We have this dog that is excited every single day. Like, he just loves days. He's super into dynamics, because every day it's like, woo, it's a day, I love those.
Dude, I'm your dog.
Hell yeah. Right, so dynamics is just doing the same thing over and over again. Like, you try that same thing, and you kind of look at long run behavior. You have some weird ones. What else? You guys know? Any others?
I know a bunch of chemistry stuff that we use.
Yeah, a bunch of chemistry stuff.
Oh yeah, we could play.
Yeah, that's actually one of these kind of population type things. Right, the population you're thinking of is like the unreacted stuff. What's the half-life?
I know that it's LN2 over something,
Yeah, so the half-life is a radioactivity thing.
but I can't remember the.
Okay, should we figure it out?
And we don't have to. I just can't remember it.
We can. It's chill.
Why?
It'll be one of the, because it'll be one of the examples I do anyway.
Okay.
Okay, so there's some more stuff. Some more of the stuff that you use these for, like springs. Well, kind of. Differential equations. So anytime you know something about the rate at which something happens, right? Like, I know, for instance, that the rate at which my beer cools off or warms up is proportional to the difference in temperature between my beer and the ambient.
Right.
Right? That's like Newton's law of cooling.
Yeah.
That's a differential equation. When you solve that differential equation, you get an E in it. Because E's oftentimes show up in differential equations because they have nice derivative properties. So this gets used kind of every day. If you know one class of functions, it should be this one. Like if you want to purge trigonometry, this is what you should replace it with. Cool? Don't purge trigonometry, you'll fail everything.